Hello everyone, I'm Miss Felicia from the Bukit Timah outlet of OVERMUGGED. So maybe before I begin, I just give you a short introduction of maybe of myself. Because I think some of you never seen me before, or maybe never even heard of this tuition center before. So this is my name. Usually my students call me Miss So for me, I've been actually teaching O-level and IP, all three sciences, all this while. Then I previously graduated from NTU from the degree of science. And then I am actually now teaching both upper sec and lower sec. So I actually have Nanyang classes for the lower sec, which is your juniors. So I actually have sec 1 science class, sec 2 science class also. Then I think some of you know some of them here are existing students in upper sec. So previously I've taught 7 years in the learning lab. I don't know whether you all heard of this tuition center before. So I taught until last year. Then I quit to join OVERMUGGED here. Then even before learning lab, I was teaching actually at Queensland. I think maybe you also don't know, right? Because last time at learning lab, I never review where I teach at. So then I also taught at MOE schools as a relief teacher, for 2 years. And long time ago, not in a faraway land, but in Singapore, I also taught as a private tutor. But nowadays I only do group tuition. So in case for you are wondering, how come the center is it very small? Is it just 2 classrooms? But no, actually we have 4 different outlets. It's just that for Bukit Timah we only have 2 classrooms. So for IP classes, it will be conducted at Bukit Timah. That's why you are here today, because this is where all the IP schools are at. So we also have other branches, but the other branches are more for O-level and express classes. So IP is only at Bukit Timah, which is I think is good also because it's near your school too. So then for the subject tuition for IP science, IP subjects, so these are the teachers. So I believe you all will be seeing Mr. Dixon soon later for the next session. Then just now it was Mr. Pang that taught you all, right? So this is me. And there's the math teacher that you all might have attended last week with her. So for right now, we have classes for LA, physics, chem, bio, and math for IP upper set. So just to share a little bit more with you all, because just to let you all know, some of my students who are here with me also. So is that for us, our group tuition, it will be that we usually will go in depth, and then the lesson structure is that we will also follow your school scheme of work. That's why the worksheets that you are receiving today are actually what I use in my actual chemistry class, which I go through with my chem students. Because we will include revision for WAs and end of year. And in one classroom, maximum is 12. So normal regular tuition, we won't be squeezing 3 people in one seat. In one table, I mean. So it will be maximum only 12. So that you all can sit comfortably. And most of my students are from Nanyang, because previously at the learning lab, I was teaching mainly the Nanyang syllabus and the RI syllabus, referral institution. So that's why my student majority are from Nanyang, because I don't know, it feels easier to bond with girls than guys. Guys bochap. That's why it will be hard to stay close with them. So that's why in the end, my classes now end up a lot of Nanyang students. Then during tuition, we also go through topic by topic. So the notes on electrolysis that you receive is really the topic by topic note. So this is just one of the chapters inside. Then usually the class, we don't want to make it too big. We keep it to maximum 12. Is because students will be free to ask questions anytime. And then we also have our own curator worksheets, which you all will be receiving soon. I'll be giving you a worksheet on electrolysis and rate of reaction. Then usually when we reach Sec 4, there will be mock test session. I think my own students also don't know yet. I will let them know soon. So usually we will have this big scale mock exam where everyone is under exam condition, then time constraint, then you have to do your paper, then see whether you can finish in time or not. So then so usually we use latest learning materials. Then we will have gift card or even bubble tea, which you all receive it today, right? And food. So food, we will order pizza, KFC, ice cream, to class kind. So then just to share with you all that some benefits that what my students have is that besides the regular tuition that they have, there's actually this complimentary online tuition for as long as you are an OVERMUGGED student, no matter which subject. But this one is also available to the public also. So that means if you are non-OVERMUGGED students, then if you just feel that you just need a bit of help, you can actually go for this fully online tuition of only $99 a month. And it covers all subjects, including humanities, science, English language, and math. Yeah, only don't cover mother tongue, because mother tongue a bit hard, like by a different language teacher. Yeah, so yeah, we cover all subject that is in English medium. Yep. But it will be pitched at the O-level syllabus. But I think it's still okay, because like for the IP syllabus versus the O-level syllabus is like 80% similar. Yeah, so that's why yeah, you can, if you are interested, you can sign up for it. Right now actually there is a free 2-week trial, yeah, for the public. Yeah, so if you want, you just go over to OVERMUGGED's IG, their bio, then you can just attend a 2-week free trial. Yeah, so there are live lessons and recorded lessons also. Yeah, then each month is like 16 to 18 lessons. So if you go and calculate, it's just like $5 a lesson. Yeah. Yeah, but this one is fully online, okay? That means like your lesson materials is also soft copy. Then the lesson is also online, no physical. So physical, it has to be the regular group tuition. So this kind is like maybe physics wise, maybe like 2 lessons a month. Then chem 2 lessons, maybe bio 2 lessons. Then humanities maybe just once a month, that kind. So it's more of like just to give you extra help. Yeah, so for our own OVERMUGGED students, this is given to them for free. Yeah. So then, yeah, anyways, just to let you all know, maybe after the lesson, you'll find that just now maybe Mr. Pang's lesson very good, like you want to like sign up for his class, or maybe in future like JC, you want to sign up or what. Yeah, so right now, just to let you know is that if you heard of any friends who are Sec 1 to Sec 3 age range, right, there's actually this referral fee program where only if you yourself is an OVERMUGGED student, then you refer to someone that is Sec 1 to Sec 3, you can get $100 cash from me. Yeah, so Jazel like got it from me before also. Oh, because Sec 4 graduating, that's why Sec 4 not included. Yeah, but Sec 1 to Sec 3s are counted. Yeah, so if you manage to recommend maybe your juniors to join OVERMUGGED tuition, then but you yourself must become OVERMUGGED student first, so that I can give you the money, right? Yeah, so that I can see you, because it's given in cash. Yeah, so then you'll also, if you manage to get anyone to sign up, then you yourself is an OVERMUGGED student, yeah, by 30th June, I'll give you really cash. It's really legit cash. Yeah, that cost, yeah, I gave it to Jason before. It's really $250 cash. Yeah, then given to you, okay, not to your parents, okay, the $250. Yeah. Then if your friend like say, hi, I never even hear of OVERMUGGED, I don't even know what this tuition center is. So if they are not sure, you let them know. There is actually totally free of charge trial classes. They can attend like 1 lesson first to see, oh, the teacher's teaching style, how is it, whether suit them or not. Then if they like, then they then sign up. Yeah, can also. So likewise for you also, like, yeah. So if you want to like try out a real lesson, yeah, you can let me know. Then I can arrange a trial class for you. Yeah, any subject, you can just let me know. I can help you to arrange also. So if you are keen in tuition, maybe you feel that your Sec 4 you're struggling. Anyways, here's the rates depending on the lesson day, weekday or weekend. So every lesson we will definitely provide you worksheets, notes, yeah, everything that you need. Yep. Then there's also consultation available like before, after class. But usually my students tend not to do consultation. They usually text me on WhatsApp. Yeah. Then I will just answer whenever I can. That's faster, right? Yep. Then homework wise, usually it's flexible. I do give homework, but near WA usually I tend not to give homework. Yep. Then yeah, some other makeup option. I think maybe some of you all know them and you're inside, you're featured. Yeah. Okay, so right, yeah, so just to show you, yeah, so this is the one that I was saying, like the big scale mock exam for Sec 4s. Yeah, so to like prep you for like exam conditions. Yep, then yeah, so these are like the food that we ordered. So bubble tea, you all saw it today, right? Yeah, then that is like donuts that's ordered. Usually you order like really a lot. Yeah, then for the, yeah, this is the notes that we use for lesson. So in case any of you feel that, you're the very independent kind, nah, don't need tuition, right? But then maybe you need extra notes. The notes are also available for sale at, I can't remember the exact price. It's about $40 to $50 price range. But it includes the first chapter in Sec 3 all the way until the last chapter in Sec 4. Yep. So I actually printed out the electrolysis notes from these notes. So the notes that you receive now is actually from the booklet itself. Yep. And the worksheets you will receive later after I finish teaching electrolysis. Yeah, then we also use latest exam paper, which later you can see the exam questions are usually we pick is all within 5 years. Yeah, that means we don't choose very old papers. So that is like up to date to the syllabus. So in case in future, if you or your juniors or your cousin or your siblings, anyone want to like sign up for tuition, you just feel free to contact me since you all have my number already. Yep, so take note, if it's the Nanyang class, confirm at Bukit Timah outlet only. Yep, so done. That's all for my self-intro. Okay, so let's begin with the electrolysis topic. Okay, so luckily only 2 chapters. Oh, don't need to rush so much. But just now my previous class, and I think your bio lesson also, right? Like so many chapters, then need to rush and rush and rush. Yeah, okay, luckily came a bit less topics, more manageable. Okay, so anyways, sorry for the typo over here. Can you help me to switch them around? Thank you. Okay, so for the first half of electrolysis, I'll be actually using this slide to go through. Okay, so need to know that for electrolysis, this chapter is divided into a 4+1. The first 4 is that there are dry cell. Okay, so with dry cell, this is the 4 scenario. And then +1, 1 is without dry cell. That is called the simple electric cell. So for the first 4 over here, how to remember? Like, because sometimes you don't know like who should you discharge and what to choose, right? So what you do is that you just take note. As long as cathode, right, you always follow the table of the electrochemical series table. So whenever it's cathode, right, just follow that table. Okay, so which table am I referring to? Let me show it to you in my notes. So it is actually this table. Okay, so whenever it is a cathode, always follow this table of cations. Okay, by the way, why do you refer to the table of cations? So just to do a quick recap over here. By the way, just to let you know, I keep jumping here and there on the notes. So sometimes I will use my slides. Sometimes I will use the curated notes, electrolysis notes. Okay, so now I'm at the electrolysis notes, not the slides. Okay, I'm at the electrolysis notes, not the slides. Okay, so over here, maybe I just do a quick recap on how do you even decide like which one is cathode, which one is anode. Okay, so what you do is you look at the dry cell terminal. Positive terminal means this is a positive electrode. If it's a negative terminal, means this is a negative electrode. Then for positive electrode will attract minus charges, because if you are plus, you will always attract minus, right? Yeah, so that's why if you attract minus, take note, anode always attracts anion. That's why the name is similar. Anode attract anion. Okay, so that means if you attract anion, means ta-da, your identity will be called an anode. So anode is a anode is a positively charged electrode. That means it's a positive electrode. Then next on the right side over here, so this one is negative terminal of dry cell. So this is a negative electrode. So this negative, they will attract positive charges, right? So since they attract positive charges, that means you attract cathode, you attract cation, and cathode attracts cation. Then next is need to know what kind of reaction is happening. Like, is it oxidation or reduction? So I usually teach by this mnemonic called red cat and ox. Yeah, so that means a cat that is like red color, and then 1 buffalo, 1 ox. So red cat means reduction at the cathode. Then anode is oxidation. So that's why once you find out that this is cathode, then you can go by cathode is red. So that means cathode is reduction. Then just to do a quick recap in the topic of redox, reduction is you gain electron. Then next over here, an ox, meaning at the anode, it will be oxidation. So oxidation from the topic of redox is that you lose electrons. Yeah, then lastly, take note that for electrolyte over here, the electrolyte has to be a ionic compound. Yep, because you need them to form ions so that they can be a mobile charge carrier to carry charges and to let the charges flow around. So can you all make sure that you note down everything that I've shown here? So everything that I've shown here, you write it into your notes. So I'll just gauge based on those who are physically here. Once they're done copying, I take it that those online should be done. Okay, so moving on. Okay, so next part over here, actually all these are all repetition of what I've went through. Okay, so like see everything that I say about oxidation and anode and stuff. So all this is just repetition. Yeah. So all this I take it that you should be okay already since I explained it. Okay, so now I'm going to jump back to my slides. So can you all switch over to my slides now? So that's why what I'm trying to say is that which one is cathode? So now we know it's actually the negative electrode, because cathode attract cation. That's why you see cation. Okay, so for this as long as it is cathode, it's very easy one. Cathode always follow the the metals reactivity series, just like that. It is the anode that is the tricky one. Okay, so let's take a look at each scenario one by one. So for the first one is molten. Molten is very straightforward, right? Molten sodium chloride means you only got sodium and chlorine. So of course you discharge these two. So don't need to study much. Very easy. Let's move on. Dilute. When dilute means got water. So that means you need I will always recommend that you write out the ions, like there's H plus, OH minus, Na plus, Cl minus. Always list out the ions. Then you circle the one. Yeah, so which one to circle? Cathode, you base on the table, you circle the ones at the bottom of the table. So if I go back to my electrolysis notes, not the slides. So for the notes over here, in this list, take note that the one at the bottom is the first to discharge. That means if you want to select, you want to circle who gets discharged, you circle the below one. You choose the ones that appears below. The ones on top, it will be the last to discharge, or so-called never ever get discharged. Yep, so that's why in this case, it is like maybe you have NaCl in dilute, is a dilute solution of NaCl. So solution means got H plus, right? Because solution means water. Water got H plus and OH minus. So got H plus, and then Na got Na plus. So H and Na, you choose H. You always choose the ones at the bottom of this table. So that's what I'm trying to say, that it is that you select from the table. Anode for dilute is still the same. So for anode, you also follow the table. So that means over here, you just follow this table. Yeah, so you just follow the anode table. So for the anode table, right, it is very straightforward. Why? Because it's just mainly two things, hydroxide and halogens only. Because for sulfate and nitrates, they are never discharged. Okay, you can never ever discharge them. So it is whether do you choose halogen first or do you choose hydroxide? Right now I'm in my notes, not the slides, notes. Yep, so how do you decide which one to choose? In other words, to make it simply, choose the one that is more. So which one you have more? Yep, so for dilute means you got more water, right? So we choose water, that's why you see, water gets discharged. If it's a concentrated salt solution, that means you have a lot of chloride. That means you discharge chloride, so you choose chloride. So you choose the one that is more. Do you have more hydroxide or do you have more of the chlorides? Okay, so just choose the one that is more. That's all. Then sulfate, nitrate, don't need to choose, because can never ever get discharged. Done, noting down, right? Okay, so continue on. Then next is for concentrated. Okay, so for concentrated, cathode always the same. Anode, as mentioned, choose the one that is more. Okay, so for dilute versus aqueous, the anode just choose the one that is more. You can write it down also. Choose the one that is more. Yeah, so if it's dilute, that means you have more hydroxide. Then if it's concentrated, you will have more of the like chloride or bromide. Yeah. So anode always choose the one that is more. Okay, so all these are for inert electrode. Okay, so for scenario number 4, we will change it to reactive electrode. So how do you decide if an electrode is reactive or not? Is that sorry, can I just double check for those online? Are you all still able to hear me? Because I have this pop-up sign that says that I got logged out of Zoom. Can you still hear me? Can I have some responses like in the chat, like yes or no? Can you all still hear me? Oh, Cheryl responded yes. Can, right? So the rest still here. Okay, luckily, because my Zoom really got locked out. Yeah, so I don't know like what happening there. Like you see, like wait, where's my mouse? Yeah, cause like my Zoom is like got like that, like I totally get locked out. Okay lah, since you all can still hear me, then it's all right. Okay, then I continue. Okay, so when it's a reactive electrode, how? Cathode still the same. You see, cathode always follow the table of cation. Okay, no change. It is the anode that is different, correct? I told you only anode change. So if you know that they are reactive, of course, one of the electrode must react, right? Since cathode is the same, that means it's the anode that reacts. So it's the anode that corrodes into the solution. Okay? Yeah, so it's the anode that corrodes. So when you corrode, it will be like solid state. You become into the solution, so it becomes aqueous state. Okay, so done. I move on. Okay, so moving on to the next part over here on electric cell. So for electric cell is when there is no battery. So that's how you differentiate, okay? Electric cell is no battery. So then how do you know what happens? So for the negative electrode, it will be the one that is more reactive. Okay, the negative one is the more reactive one. And then the less reactive one, it will be the positive electrode. So I don't recommend memorizing by heart. That's very hard to remember, very easy to get confused, like which is plus, which is minus. So go by understanding. So how to understand it? I am going to jump over to my notes now. So no longer the slides, I go over to my notes. So for my notes, can you flip like quite behind, because the electric cell is behind. Can you flip to this picture, which has the title called Simple Electric Cell? Flip to the page called Simple Electric Cell. Okay, so for simple electric cell, usually I would prefer that you write these two as like the terminal of the dry cell. Yeah, because this time around, these two are like your batteries lighting up your light bulb. So for reactive, okay, so you can know that from reactivity series, zinc is more reactive than copper, right? So it is more reactive. So for metals, generally for metals, which is on the left side of the zigzag line in your periodic table, metals tend to be charged 1 plus, 2 plus, 3 plus. That means they tend to lose electron. So if they lose electron, that means if you react, that means higher likelihood, more likely to lose electron. Yeah, can you follow and write it down? More likely to lose electrons. So since they are more reactive, means they are more likely to lose electron. That's why you see, you shoot out electron. Also, that means you remember that the more reactive electrode always shoot out electrons. And because they are more reactive, that's why you shoot out electrons. So if you shoot out electron, isn't it like, like dry cell? The negative terminal will have electrons coming out, right? So that's why this is like the negative terminal of the dry cell. So I would say that zinc electrode is the negative terminal of a dry cell. Okay, because it shoots out electron like the negative terminal of the battery. And hence, copper will be opposite. So copper, it will be the positive terminal instead. Yeah, so since zinc lose electron, that means zinc is actually changing from Zn solid to become Zn2 plus, right? Because you lose electron. Yeah, so that means in this case, zinc is going into a solution. Also, that means the more reactive one will go into solution, which makes sense, right? Because if you are very reactive, means you want to react into the solution. So that's why the more reactive electrode will go into the solution. That's why if I were to now jump over to my slides, that's why I mentioned more reactive metal will corrode into the solution. Okay, more reactive will corrode in. How about the less reactive? The less reactive will follow the table of cation. Yep, so that means same thing. So just remember, no matter is whatever scenario in electrolysis, right? You must always have one of them always must follow the table of cation. So table of cation is like a compulsory to use kind of thing for all scenario. So over here for copper electrode, this one, let's label it. This one, you follow the table of cations. A shortcut can just, which table I'm saying can already. Yeah, so it's the table of cations. Then you see who gets discharged as per usual. So you look at your solution, dilute means got H plus, OH minus, sulfuric means like got SO42 minus, and then you just circle, see which one to choose. So you see which cation to choose. Okay? So this time around, the cation is H plus. That's why hydrogen gas. Yeah, like that. Okay, then going back to the slides over here, next is need to know like whether is it oxidation or reduction. So you can actually simply go by what I mentioned here, right? If you lose electron, isn't it oxidation? And then just done already. So the more reactive is oxidation. That's it. So you see, there is no need to memorize. The only thing you need to memorize is the reactivity series. The rest should be by understanding. Okay, so that's why more reactive is oxidation, cause lose electron. Lose or shoot out electrons. Remember, more reactive always shoot out electrons. Yep, so in other words, electrons, since shoot out from the more reactive side, that's why electron always flow from the more reactive to less reactive side. And then this one, I think you should know, the greater the difference in reactivity, the bigger the voltage reading. Yep, then over here, the next few slides are all answering techniques. So that means like whenever question is on molten, you just flip to this page, copy and paste the answer in, can get full marks there. It is, so this is for cathode. This for anode. So how come got two paragraphs? Is because this one is for explanation. So this is for explanation. This one is for observation. So explanation is like you must tell me, oh, what are the ions? Observation is like your sight, like oh, you see bubbles, you see the metals. Yep. By the way, just a reminder, quite commonly confused. Iron is actually a gray solid. Because I think a lot of y'all thought iron is like, iron 2, iron 3, got what? Green, got brown. But then actually, the one is aqueous. If it's a solid state, it's a gray solid. Okay, then over here, yep, so likewise, the top paragraph is like explain your answer. Below is like state the observation. So these are the model answers. That means all the pages that has answering technique, please go and memorize it for your test. All the answering technique ones must memorize for test. Then from molten, now I change to dilute. Dilute also model answer here. Then one of it become the reactive electrode, right? Scenario number 4. This is the model answer. Then this is the anode. And then if concentrated versus dilute, dilute is this paragraph, concentrated is this paragraph. Yeah, then next is like sometimes they will ask you, right, like the part C or part D, describe the change in electrolyte and explain your answer. So these are the answers. And all model answer, like just memorize it, like sweet, nice for you. Just memorize it, you can score it already. Yep, so done, that's all. Okay, so let's try out some questions on electrolysis to see whether you understand it. So let me distribute the worksheets. Electrolysis. Do you have this worksheet before? You all take one and pass. So for the electrolysis, this worksheet, let's see. Let's do a question together. Wait, you give me a moment. Hold on. Let me get my answer key. Oh, sure. I got a lot. Okay, let me see which question shall we do for this worksheet. Let's take a look at let's take a look at question number 13. Yep, so can you all flip to question 13 and then can you all read through first? Yeah, question 13. Hello, are you looking at question 13? Okay, I read through with you. Okay, so they said that 2 experiments were conducted concurrently. In experiment 1, a constant current was passed through a concentrated solution of potassium bromide using inert electrodes for 60 minutes. Then in experiment 2, the same current was passed through molten lead-2 bromide using inert electrodes for 60 minutes, and they record. Okay, so the whole chunk is just trying to say that one experiment is concentrated, the other one is molten, full stop. That's it. Okay. Then moving on, so they tell you that, these are the observation and all. So part A, identify the shiny gray solid formed in experiment 2 and explain why it sank to the bottom. Okay, so maybe I think we need to analyze it. Okay, so over here, yep, so let's look at it one by one. So for the first one here on concentrated potassium bromide solution, so let's write out first. So what are the ions present for concentrated potassium bromide? So you obviously have potassium, right? Then you also have bromide, right? But concentrated means there is water, correct? So water means you got H plus and OH minus. Okay, so then now let's choose which one to circle. So for the table of cations, remember cation, we always follow the table, right? So between H and K, who should we select? H and K, who should we select? We should select H. So that means, in other words, the gas produced here is hydrogen gas. And so this gas here is hydrogen gas. Okay, then next, between Br and OH, remember I told you if it's concentrated, the anion you choose the more one. So which one got more? Br or OH? Br, correct. So that's why in the end, you discharge Br. So this yellowish brown thing, yeah, it will actually be bromine. Okay. Okay, then next we continue. So after 30 minutes, still got colorless gas. So okay, that means it's the same answer still hydrogen gas. Then they say that further darker means yellow, you have even more yellowish brown. So you have Br2. Then next one, after 60 minutes, still colorless gas means still got hydrogen ions. And then the other electrode, so you see this is one electrode. The other electrode also colorless gas. What happened? How come the bromine suddenly from further darken become colorless gas? Do you have any idea what happened? So what happened after 60 minutes? So what happens? How come suddenly the yellowish brown darken suddenly colorless gas? What's happening? What's going on? Any idea? Oh, so I got to this worksheet last time. I did before. Oh, okay. So maybe can someone maybe contribute the answer? How come suddenly from the bromine darken and suddenly colorless gas? Bromine is not colorless gas, right? So what's this? I give you a hint. If you keep on discharge bromine, means you have less and less bromine, right? So do you think it will stay concentrated? So it become dilute. Once you become dilute, who should I circle? Should I still circle bromine? You circle OH instead, right? That's why over here the colorless gas is, who is it? Gas is not OH, I guess. OH will form what gas? OH will form what gas? Oxygen. Correct. So that actually over here is oxygen gas. Okay? Yeah, like that. Okay, then now we move on to the right side. So for the right side, this time around is molten lead bromide. That means you only got lead and bromide, right? So obviously it's like very straightforward. I think all of them are just lead and bromide. So maybe I do this one yellow. So lead is the shiny gray liquid, shiny gray liquid, shiny gray liquid. Then bromide, maybe I do in green. Bromide, it will be the reddish brown, reddish brown. Then bromide use finish off, no more reddish brown. Very straightforward. Okay, so now we should be able to answer part A already, right? So for part A, identify the shiny gray liquid formed in experiment 2. So what is the shiny gray liquid in experiment 2? What are these? What's the shiny gray liquid? What is it? Lead lor. Can you write it in? Lead. So the answer is lead. You're done copying, right? Okay, so moving on to the next part. So for part A, done with identifying, next is explain. So why is zinc? This one is not really chemistry. Yes.
Why is bromide like yellowish brown, then number 2 is reddish brown?
Bromine is just generally around brown in color. Yeah. So why is it slightly different tone? That one I'm not very sure. Just as long as you see brown, it's just bromine. It's just in different states, it will tend to be different color. Something like, iodine, when it is a solid, is a black solid. But once you become gas, it becomes violet. But why is it black and violet? I also cannot really explain. It's just like that. Yeah, so it's just different state, then the color turn a little bit different. Yeah. You heard of like iodine solid versus gas is like black versus violet, right? You hear before? It's in the topic of periodic table. Yeah. Okay, so anyways, I continue on. So over here, explain why did the solid, why did this gray liquid sink? This is not very chemistry, this is like general knowledge. Generally, why object sink? Why object sink? Denser? Yep, correct. That's why the answer is that lead is denser than water because you put it in water. You written down the answer as lead for the front part already, right? For the identify. So this is the explain part. Yeah, so explain is lead is denser than water. Okay, then moving on to part B, write relevant equations for the different observations made in experiment 1. After 5 minutes, and after 60 minutes. Okay, so over here, right, yeah, I think you'll see 4 mark, you also seen. Yeah, that's why I'm going through it. Okay, so generally just take note that in your answer, right, what are the 4 key points that I need will be number 1, of course, you need to write the equation. Then in your answer, right, how come suddenly the bromine one change? What causes the result for the bromine to change? Correct, it's the concentration. So that means in your answer later, you also need to include about the concentration. Yeah, so you must tell me, oh, concentration of the bromide, how is it? Can you write down key points at the side? Then after you write down already, then next is we go and circle, right, which ion we choose. So the circling thing, what is it called? Like I circle Br, I don't circle the other one. So when you circle, what is it called? Correct. Yep. Either selectively or preferentially discharged. Yeah, but for Nanyang, best is that you'll not only say the word discharge, you should plus N something like N oxidize or reduce. So to decide whether is it oxidized or reduced, you go by the red cap and ox. Then once you identify, oh, if you think that is reduction, then is anode, right? Then it's anode attract N ion. So that means the N ion that undergo reduction. Okay, yep, so you write this. Then after you're done writing this already, then have to link to the question, right? Because they're asking you link to the observation. So that's why step 4, it will be, you tell me, so what is the observation? So this will be the answer. So that means you need to write these 4 points for after 5 minutes. And then you need to write again, same 4 points again for after 60 minutes. That means your answer will be really very long. It will be like 2 chunks of answer. Okay, so each one, because in upper sec it's like 2 points get 1 mark. So like point 1 and 2, 1 mark. Then 3 and 4, 1 mark. Then you do for after 60 minutes also. Okay, so I leave it to you to complete it on your own. Anyways, no worries, because at the end of the lesson, I'll be providing the answer key for all the worksheets that I'm giving today. Yeah, so then you go home, do ready, you can check your answer. Okay, so moving on to the next page. After 30 minutes, explain why the solution turned alkaline in experiment 1. So based on what y'all notice over here and all your annotations, anyone can suggest to me what do you think is the answer? Anyone can suggest to me what do you think is the answer? So based on what you circle and all, why did it become alkaline? Anyone? Can I have answers? People, it's nearing to your WA, but right, you should be able to answer me. Oh, you know the answer, is it?
H plus got discharged and the concentration decreases.
Yes, correct. Very good. Thank you. Your name is?
Riqi.
Oh, okay. Thank you. Okay, so thank you, Riqi, for the answer. So yep. So in this case, yeah, it's because of, I don't know whether you all heard her, it's because H plus got discharged. Because H plus got discharged, that's why in the end you only left with like OH minus, right? And OH minus is alkaline. So that's the answer. Come, let's write it in. So mainly it's because which ion are preferentially discharged? You want to copy down the answer? Oh, okay. Sorry. Okay, so maybe can I get Ziqing to answer me since the number of names I know here is limited. Okay, so Ziqing, can we fill in the blank? So what's the first blank here? Okay. Then this one? Yep, correct. Oh my god, oh my god, I'm missing a spelling E, but never mind. Okay, or no. Then? Correct. Then concentration of? Yep, yep, correct. Becomes? Yep, correct. Good. Yep, so these are the answers. And those of you who have already completed, can you like double check and make sure you fill in the blanks correctly? Don't fill in the blanks wrongly. Okay, so moving on to part 2, the volume of original liquid was reduced in experiment 2. So then, yeah, they ask you to explain why. So do you have any idea why the volume of the liquid was reduced? What happens? If the volume reduces, then the substance go where? How come my liquid get lesser and lesser? Where did my liquid go to? Anyone online can help to contribute the answers to. You can type it in the chat or you can unmute your mic to tell me. How come the liquid become less and less? So where did the liquid go to? Where did the liquid go? So where did the liquid go to? Nobody knows the answer at all. Or maybe for those of you who attended my lesson already, like Jazel, Linky, Alicia, Stingray, do you remember what's the answer? Since we did this worksheet in class, do you remember what's the answer? How come the liquid become less and less? Something like evaporate lah, yeah. Because once you go into the gas, then you escape, then lost already, right? That's why you have less and less. Yeah. So this time around, what is the thing that like evaporate? It's bromine, correct. So volume of liquid was reduced is because the bromine actually is produced, right? And then when they produce, it is actually become gas. Then it will escape into the surrounding. Yeah, so that's why it become less volume. Yep, that's the answer. Yeah, let's write in the answer together. So mainly it's because bromine gas produced at, can you specify which electrode is it? So which electrode? Yes, correct. Because anode attract anion. Bromine is an anion. Okay, so anode attract anion, cathode attract cation. Okay, then for the last part over here, part D, they're asking you to predict the final color of the solution after 60 minutes. Okay, let me just shift it up. Okay, so what do you think is the color after 60 minutes for experiment number 1? Experiment 1. So what's the color in the end? Colorless, good try, not correct. Because it became a dilute potassium bromide solution, right? Yeah, so if it's the dilute potassium bromide, and just now you still have the bromine that is in the solution. Yeah, so some become gas, but there are still some bromine in the solution. So actually it should be a reddish brown solution. Because if you look at after 30 minutes, it is still reddish brown and it's a super dark color. So even though some bromine escape, are you sure that really all bromine escape? Not all bromine escape yet. So that means it's more of a light reddish brown color. Yeah. Okay, so the answer is reddish brown solution. Done. Okay, so then done with electrolysis question. Let's try out an electric cell question. So let's take a look at question number 14. Okay, so for question number 14 over here, can you all give it a try on your own now? I don't want to guide you anymore. You try on your own because the answer very short. Yeah, so can you fill it in on your own now? Due to time constraint, I think you just do part A and B will do, can just to make sure that you know what's electric cell. Just A and B will do. The other parts you try on your own at home. Or unless you're very fast with A and B, then you can do part C onwards, meanwhile waiting for the rest. Yes. Yeah, can. Anyways, right now I will also take it like a toilet break now that you are doing your work. So if you need go toilet, can you go now? Because after the toilet break, then I'll resume with lesson already by going through the answer. Okay, so if you need go toilet, you go now.
What do you mean? This is new. Sure. Because electron one is shoot out electron. Okay. Shoot out electron. You find it more reactive. More reactive is the because this one shoot out and then unless shoot out means more reactive. More reactive is the negative one. She looks so bad. But after that, it's a try, right? You should share most of the stuff. This one is easy because this one is reactive. How do you know the picture of this? It's a try. It's a try. I know it's a try. Yeah, but like what else is there? But like this sort of thing, both sides are usually reactive. Reactive, and not is and not is a different assumption. The thought is because it's reactive and then this one is shut.
Whenever you're not sure who to choose, right, you just refer to the slide. All the slide I summarize it, like who to choose. Yeah. Yes, correct. More reactive always shoot out electrons. I will double check for those physically here. Any of you still want to go and get some snack or what? Because I know that some of you are staying throughout and like might not have lunch. You get more snack or anything because I'm about to start the lesson now. Okay, no worries, more issue. Okay, so I shall resume with lesson now. You haven't even start doing? Oh, okay. You start doing now then. Wait, our lesson should end by what time? Oh, I cannot remember. I need to check the schedule. End by 4. 20 more minutes. Okay, I think I need to go through the answers soon because still got the rate of reaction.
Yeah, that is simple.
Or is it more simple?
I know, right?
Electrolytic. Okay, so I hope you all managed to complete like at least some parts. Okay, so here's the answer for the part A and B. Okay, so for part A, part 1, they asking you to use arrow to draw the electrons. So remember, the more reactive electron shoot out, sorry, the more reactive metal shoot out electron. That's why you must shoot out the electrons, okay? Yep, then next is determine which one is cathode, which one is anode. So for this case, the more reactive one, it loses electron, right? So if you lose electron based on the topic of redox, this is oxidation. So if it's oxidation, that means this is red cat and ox, that means this is an ox, so this is the anode. Yep, so if this is anode, then it will just keep on alternate. So that means if this is anode, this is cathode, then anode. Then it will just alternate. It will keep on alternate one. Yeah. So that means if this because you see why is it alternate is because you realize this one receive electron. Can you see the electron go in? So if you gain, okay, right below. So this one, if you gain electron, isn't it direct opposite? That means it will end up become cathode. So if this is cathode, the other one will be anode. Okay, so that's the answer. Then moving on to part B. Okay, so for part B, they are asking you to write the ionic half equations. So for iron and zinc electrode, then remember the reactive one, they will always react, that's why they will corrode in the solution. That's why it becomes aqueous. Then for the iron side, you must always, one of them must always follow the table of cation and circle, right? So you must remember, okay, no matter what scenario, always one of them must follow the table of cation. So since the reactive one reacts, that means the less reactive one follow the table of cations. Okay, so that's why it is, you circle, in the end you circle H plus. Done. Okay, so the rest of the question, I'll leave it to you to complete it on your own. So at the end of the lesson, I'll provide you the answer key. So let's now move on to rate of reaction. Okay, let me distribute the worksheet. The rate of reaction is easier, that's why I'm also leaving it less time. One part down. Right. I give you some short-term memory. Okay, so yep. So moving on to the speed of reaction. Yep. So take a look at the notes bar. Okay, so for speed of reaction, right, is a much easier topic. So things to take note of is that whenever it is like they might ask you what kind of experiment can you conduct to perform rate of reaction. Yep. So one of it is that you can use the gas range to measure the gas. And take note, okay, whenever they ask you to describe versus explain, describe is always based on the gradient. Explain is always the rate of reaction. So take note, describe versus explain, don't use the wrong thing. And since this kind of question always got graph, as long as graph and table must always cite the value. So this is a skill that you also need for other sciences also. So whenever got graph, can write down graph / table must always cite the values. Okay, remember not only for chem, for physics, bio also the same thing. Whenever got graph and table must put the number like 10 or what 20 and stuff. Okay, then another method is the change in mass. Yep, so take note of the graph, need to know how to draw it. Then the describe, explain, describe in terms of gradient, explain in terms of rate of reaction. This one is less used, but this one is more of like, when will the precipitate form until you cannot see the cross? And then you stop the timer. That's called opacity. Okay, then all these are work example, which you can just read it on your own. I take it that you can read, because the answers are all provided. Okay, then next over here, factors affecting rate of reaction. So you need to know that total there are 5 factors affecting rate of reaction. Pressure is only applicable for gas. Okay, pressure is only for gas. So if it's liquid or solid, cannot talk about pressure. And for all of them, the graph, right, will always have the same endpoint except 2 factors. Okay, so take note that all of them will have the, so all except 2 factors that will be like this. So what are the 2 factors? The 2 factors will be number 1. Okay, maybe I wait, let me I think I write a very ambiguous. Wait. Okay, maybe I write like that. Okay, so all 5 factors will be same endpoint. Only 2 factors then will be different endpoint. So different endpoint meaning like that. This is called different endpoint. So only 2 factors will have different endpoint. 1, concentration, and number 2, mass of limiting reactant. So once you see the word limiting reactant, or like, you know, sometimes they give you like the mass or like the volume, then if they give you for 2 substances, you go and first identify who is the limiting reactant first using your mole concept knowledge. Yep, so once it is the concentration or the mass that change, your endpoint is different. Why? Because for concentration is mole per dm cube. Mass is like, you know, mass is equals to the mole times mr. Do you realize that both of them definitely will involve the mole? So once your mole change, that means your product form will be different. So over here for my y-axis, this is actually the volume of the product. Yeah, because once my limiting reactant increases in number, then my product form will be more, because last time limited by the limiting reactant. If I have more means, yeah, I can produce more product. Okay, or concentration also, because you increase the mole per dm cube, I got more moles of limiting, I can have more moles of product. Then the rest of the factors will be same endpoint. Why? Because the size is just make it fast or slow. The amount of product form is the same because you still use the same gram of substance. Concentration here is more for concentration of limiting. So the 5 factors here, right, includes concentration of the excess reagent. So maybe if they were to increase the concentration of the excess reagent, then yep, you will get a steeper graph. You get a steeper graph. Okay. Then if I increase the pressure, also steeper, increase temperature, also steeper, have catalyst, also steeper. Okay, so take note, only mass and concentration of the limiting then can have different endpoint. Then next is sometimes like for questions, how do you know? Because sometimes question like to give very weird question, like they can have like that one. I show you. They can have like, wait, let me think. Like that, and then they have like that. Yeah, they can have this kind of graph one, you know. Yeah, so if it's like that, right, what you need to do is you go and calculate the number of mole first. If you realize that, oh, the number of mole of the limiting is different, right, then yeah, you have different endpoint. Okay, so you based on the number of mole of limiting reactant, you have different endpoint. So that means how to say, like I would compare, okay, graph A versus graph B. It will be more of A, right? You have more number of mole, but lower concentration. Might be lower concentration. So maybe like, you know, the mole is like mole times dm cube. So maybe they give you a lot of mole, then maybe but very low in cm cube. Yeah, so that means in the end your concentration is lower. So that means you can overall, when you press that means you just use your mole concept formula, you calculate out. If your number of mole is higher, you draw higher. If your number of mole is less, you draw lower. Then the steepness, right, is based on these 5 factors. So if it's gentler, that means lower concentration. Yeah, so you can have such scenario also. Can right? So that means mini is just following the instructions lah. Yep. So you just if you got mole, that means mini is the mole that determine whether your endpoint is same or not. Okay. Yep. So maybe wait, let me try find a question that I did with my class. Cause got this kind of graph before. Let me find it. Hold on. It's in one of my existing worksheet. Then I think easier to understand also. Where is my hold on, this one is not your paper. This one is on the worksheet that I did in my class. There is this kind of like this one. Oh, happened that it's from your school. Okay, I think it's a good example to go through also. This is not in your worksheet. This one is a question that I did in my own class. Okay, so just to share with you as a like work example, for example. So this was the graph that I was drawing, right? Lower endpoint but steeper. This is higher endpoint but gentler. So then how do you know which answer to choose? Because you have different endpoint, that means confirm the number of moles for experiment 1 will be double of experiment 2. Correct? Because you have higher endpoint. Yep, so that's why what you need to do is for each of the option in option A, B, C, D, you really need to go and find out what is the number of moles. So you can press calculator. This time this, how much? This time this, how much? You times all of them together. After you press calculator, you must make sure that you choose an option that is 1 is twice of 2. So that's why like I can check 100 times 2 and 100 times 1. So 1 is twice of 2. So yep, possible. 400 times 5, that's like 4 times 5 is 80, right? 80 and 100. This one not quite double because you can see the gap here and the gap here are quite almost the same. So this is not, wait, this is not double, but 80 and 100, wait, did I count wrongly? Let me just press the calculator. Wow, my math cannot. Wait, anyone got calculator? Maybe can help to press the calculator.
0.5 is 200.
It's 200. And this one is 100. Oh, yeah, it's actually double. So yeah, correct. So this one, the number of mole is still double, right? Because 400 half it is 200. Then this is 100. Yeah, so it's double, can. This one, 100 and 200 is the right side that is double. So wrong now. This one, 100 and, wait, this half is 200. They also say right side double, so cannot. We must choose left side double. So that means left side should be twice the number of mole. Right side should be 1 time the mole. Agree? Okay, then next is between A and B. How do you choose? So as mentioned, based on the steepness. Okay, so the endpoint is based on number of mole. The slantness, it will be based on the concentration. Higher concentration means more steep. So that's why for experiment 2 is steeper. Experiment 2 should be bigger number of mole. Yeah, so that's why B is the answer. Can understand? Yeah, so this is from your school actually. Okay, so done. Okay, so I shall move on back to the notes. Okay, then next is for all these factors, need to memorize the answering techniques. Yeah, so all these answering techniques, please go and memorize them. Okay, so all these are model answers. Yeah, concentration also, memorize the model answers. Yep, then pressure answering technique also. For temperature, because the arrow point like that a bit like confusing, so let me just write out for you, nice. So how you memorize is first, you say that when at higher temperature means got more Ke, move faster. Then second point is that you talk about the reactant particles. Yep, then the third point is you mention about this. Yeah, so this. So this is yeah, so this is the answering technique. So mainly it is 5 points. 4, 5. Okay. Okay, so I shall move on. Done noting now, right? Okay, so then the next part over here. Yep, so it's just catalyst, then it show you this energy profile diagram, nothing much. Then over here, can you help me to add this in? Because I should have this phrase. Can you add in the red color phrase?
Mine is not.
Done, noting now. Oh, your the one I print for you have. Okay lah, that's good, that's good. Okay, then same thing also, yeah, so characteristics of catalyst, I think you should know. All the word example, I leave it to you to read out on your own, can. Enzyme here not important lah. Yep, so done. That's all for this chapter. Okay, so let's try out some practice questions. So Jason, do you still want? Okay, so right, for the rate of reaction, yeah, so the worksheet I leave it to you all to do most of the questions. Then I will just like pick out some questions. Okay. Yep. So wait, hold on. Let me see which question good to do. Okay, so for the worksheet, because the question was very long, like with my limited time, I have like limited time to do. Let me see which question should we do. Okay, let's take a look at question 13. 13. Can you all read the question first? Question 13, rate of reaction. English is explanation. Okay, wait. Explain the line. Not working. Why?
I suddenly got like email friends on
Oh, can physics is it?
Yeah.
Okay, can.
Did you also bring the worksheet for me?
I can give you the worksheet I already have. Yeah, so maybe after the class I give it to you. Okay, so for question number 13 over here, okay, so for have you all, I think you all finished reading, right? Okay, so they're asking you with reference to the graph, comment on the difference in the initial rate of reaction. So when they say comment, a bit ambiguous, don't know is it describe or explain, you just write both lah. Yep, so then in this case, the difference you should mention in terms of the rate, right? So it's like faster or slower. So in this case for A, is A faster or slower based on the, yeah, it's slower, right? Because rate is based on gradient, then it's gentler. Good. So that's why for we can write down all that. For A, it will be slower rate of reaction. Why slower? Slower is explaining already, right? So maybe let's write down the describe first. Why is A slower? Because gradient. So it's gentler gradient. Yep, so that's why B is steeper. So that means you can either write A or in front of B. You can write B is steeper, that's why higher rate of reaction. Okay, then next is because with reference to the graph, remember I mentioned to you whenever with reference to the graph, what do you need to take note of? You must always, what thing, graph and table. Must always quote the data, correct. You must cite the data, the values. So then in this case, you must mention that, oh, over here, how do you tell? So maybe you can base on the time taken. Yeah, so like for the time to become like, you know, like for the graph to plateau, for B, you take a longer time, right? Yeah, then for A, you take like a shorter time. Yeah, also then this you can mention about the time taken. So that's why with reference to the graph, it's about the time taken. Okay? Yep, done. So this will be the answer. Why? Oh yeah, correct. Thanks for highlighting. Oops, I write wrongly. This one should be B. Yep, correct. Thank you for highlighting. Yep. Sorry, my B and A swapped around. Yep, so for B, it will take a shorter time. Then A will take a longer time. Okay? Then moving on to the next question. Wow, very long. Okay, so no worries. For rate of reaction, don't need set one. Why? Because whenever they ask you to explain, here very good. They even remind you collision theory means, can you just copy and paste the entire answering technique? Okay, so whenever explain, think of answering technique. I shortcut can AT, answering technique. Can you just copy the whole chunk in, then that's the answer already. That's all. So even though like 3 marks can score one. Okay? Then moving on to part 3, suggest another change from experiment A to experiment B that would have resulted in the difference in total volume of gas produced. So remember, total volume of gas different, one different endpoint. So what can we do? Different mass, but can be more specific now. Instead of just like different, this time round, do you want to use like more or less, or maybe you can tell me the gram or something? So from A to B, so from A to B, that means you want to have less gas, right? That means, yep, you should have less zinc. So that's why the answer is that you should have less zinc carbonate. So maybe instead of 20 gram, well, this is exactly half, right? So why not just directly say, I use 10 gram of zinc carbonate, or I use half the mass of zinc carbonate. Okay, so that will be the answer. Yep, so let's write it in. So it will be that you can use 10 gram of zinc carbonate. Yep, like that. Done, that's all. Okay, so for those online, I will show you the QR code. Then you scan to download the answers. For those physically, here I'll give you the hard copy.
Does the concentration not affect? What's the
It's the final number of mole that matters. So as long as your number of mole in the end is double and half, then yeah, it will be.
But then
two different endpoints.
would that explain the
The concentration affects the steepness also.
Yeah, but the steepness is different, then shouldn't the concentration also be different?
Concentration? You mean part 3?
Yeah.
In part 3, I never changed the concentration. My answer is the gram.
Then the rate should be the same. If the concentration is different.
Because this time, concentration is the
Unless
same.
you say that we increase the volume, then the less, then the concentration decrease also.
Okay, over here, right, they didn't actually ask you to identify why different slanders, like different gradient, but the difference in gradient can due to a few factors. So if you want to talk about concentration, it's not suitable because for this question, it is solid state. Solid don't have concentration. Yeah, so that means it is most likely it's about like temperature, surface area, that kind of factors that affect the slanders. Okay, so it is the gram, like 20 gram, that changes the endpoint. Okay. Okay, so done. Okay, so for those online, can you all scan this QR code to get the answers? For those physically, here I'll be distributing the answer key. Yeah, so once those online, you are done scanning the QR code, you can just stay online. So because this is my computer, I need to log out to let the LA teacher to log in. So later he will log in from his computer, then you all will enter the Zoom meeting. So although it's the same Zoom meeting, but yeah, you all will either need to rejoin or just stay there. I don't know whether you can stay in the waiting room. Yeah, so done. That's all for today. So anyways, I'm Miss Felicia here. So hope you all managed to benefit from the lesson and learn something that is important for your test. Yeah, so then that's all for today. You all can leave already. Bye-bye.